Are you doing a startup or trying to bring a new software product to market? You have a lot of choices of programming languages, but in this video, I'm going to explain why Python is basically the only realistic choice. Hi, I'm Ryan Sinnett and I'm a roboticist. Welcome to my channel, Robota Non Grata, where we discuss robotics, artificial intelligence, and technology. In this episode, we're going to discuss one of the most important choices you actually have to make when doing a startup or when building a new software product, and that is, what is the programming language or stack of programming languages you're going to use? You've probably heard people say, well, the best programming languages depends on the application and it depends on what you're comfortable with. I'm going to argue that that's a bunch of nonsense. In fact, there's a bigger difference than you might immediately realize between programming languages. Two really popular programming languages in robotics are Python and C++. Now, C++ has been around for a long time, and there was a period of time back decades ago when it really dominated the landscape. Python's been around a while too, since the mid-90s, but it's really started to catch fire with AI and machine learning. It's really come into its stride and found the killer use case. So what are the differences between C++ and Python? Well, you'll probably hear people say that, oh, you can write C++ that's more optimized, you're closer to the hardware, so you can make your code go faster, you can be more efficient. And that may be important, but when you're doing a startup or building a new piece of software, that's probably the last thing that should be on your mind. So in this video, we're going to dive into key concepts that highlight the differences and will help you make the right choice. Although, again, I'm going to argue that there's really probably only one good choice in the majority of situations when you're doing something for the first time. So stay tuned. This is about to get interesting. Number one, simplicity and speed of development. When you're doing a startup or building something for the first time, it's all about getting to market as quickly as possible. Maybe you can build a technically more sound product if you were to choose C++ over Python, but the truth is, in my experience, Python is 10 times faster to develop in. That means it gets to market a lot quicker. It costs a tenth as much to develop in terms of development costs. And you can find a lot of people who know Python these days. Now, that could be a double-edged sword because, it's not that hard to learn Python. And so the people who learn it, maybe they don't have that much experience. And regardless of what language you're programming in, programming is a way of thinking. It's, maybe mathematical if you want to think of it that way. But you can't just go from no languages to learning a language and being really effective in it overnight. You might know 20 programming languages because you've been programming for decades, and then you want to pick up a new language and you can do that in a day. But that's because programming has a few key concepts that are repeated throughout any language that you use. And the programming language is just a way of expressing a syntax for putting these concepts in the computer. Python is designed to be a really simple, low barrier to entry, easy access language. And that means a lot of people can be effective in Python very quickly. That means it tends to be very simple. It's a lot higher level than C++. In C++, you're going to be managing memory, you're going to be interacting at lower level with different devices, you're going to be passing pointers around. In Python, you can program Python, you may not even know what a pointer is. Sure, it does have pointers, you can pass a list around, which is essentially works as a pointer. You can mimic a pointer if you want because it passes by reference, but you don't even have to necessarily know that, again, to be effective in Python. In general, Python is a much higher level programming language. You can represent a lot more of what you're trying to do with a lot fewer lines of code. In C++, if you're doing algorithm development, it's going to take you so long. You're going to be getting in there. There's going to be all those edge cases. You have to manage the memory. Sure, you're using maybe the newest library, C++ 20. You've got, your shared pointers and so on. But ultimately, you're basically doing a bunch of work that people have argued that, the compiler or interpreter should do that for you. And in Python, it manages the memory for you, manages the threading. You rarely have to worry about threading situations. And so it generally is a lot easier to just get something written down in Python. I've been programming for a pretty long time. I got into it when I was a kid. I was lucky my dad had computers in the house. So I've probably been doing it almost 30 years. But when I got to college, it wasn't like everybody knew how to program. When I got to Caltech in 2003, my freshman year, they had a class called CS1, Computer Science 1. And they were teaching this class in Scheme, which is a dialect of Lisp, which probably a lot of people watching this haven't even heard of. And it was a great language because you could teach about the fundamental concepts of programming pretty effectively in Lisp, in Scheme. But today they don't do that anymore. Now it's just Python. So, if you rewind 10, 20 years, people were learning different languages, different C++ even. A lot of people would come out learning C, but now they're switching over in these universities to Python as a go-to language. And I think that's a good decision because it's just so easy to get into Python and there's so much support for it that you can really just whip something together just kind of like that. So overall, Python is a great programming language for beginners. Now, I've worked in my career with a lot of different programmers of different levels and, more junior programmers, especially in C, where it's harder to understand these tools, they don't even know how to debug effectively. They're going to add some print statements throughout the code, maybe try to cause some side effects, and really just take a very heavy-handed approach to trying to understand how the code is working. Of course, if you're a more experienced programmer, you're going to use a debugger, GDB, or maybe a better version, or better, at least, front end for that. But with Python, these tools tend to be a lot more accessible. And then when it comes to, hey, I need to test my code in a loop, what's great packages for testing in Python, similar to C++ with gtest, but there's great packages built in for testing in Python. And you can run the code in less than a second. So you can make a change, run it, get the result. In C++, and especially as the programs grow larger, you're sitting there waiting for the compiler, and then you're waiting for the linker, and maybe you run out of memory. So maybe you want to try it on a different platform. Now you got to recompile and relink it. So there's a lot more steps involved using the compiled language like C++ when compared to an interpreted language like Python. And that can play a major role iterating when you're developing the code. In terms of simplicity, another thing I'll say about C++ is, boy, there's a lot to C++. There's just so much. The spec is like 1,000 pages, and I've read through all of it, and I've spent so much time learning about C++, and so I acquired a bunch of knowledge that now I look at it and I'm like, well, I hope I never have to do that again. I hope I never have to program in C++ again because, boy, it's just so slow to get to market. And ultimately, when you're building a startup, when you're developing a new product, your goal should be to evaluate, is there a product here? And to figure out and get to the product market fit as quickly as possible. And that just means you want to use the programming language that's going to allow you to get there more quickly. You can deal with performance later, but you need to get there quickly. And so that's why, in general, when it comes to speed of development, simplicity, I would say Python is easily a winner over, there might be some other good languages, but is a very clear winner in most cases. And I'll just add, it's easy to fall into the ego trap. When you write C++, it's a lot more complicated. And, you're keeping solving all these puzzles in your head, and you're keeping, it's like, oh, somebody's going to think this is so clever. And it's really important. You don't want to fall into the ego trap. It's really easy to be like, hey, I want everybody to think I'm smart, so let me do it in a language that is more esoteric. And then people will be like, wow, how did he learn all that? How did she learn all that? But that's not your goal. Your goal is to build a product. Your goal is to figure out what the product is and get it to market as quickly as possible. Because if you don't, you're going to run out of money. Okay, number 2, versatility. There's just, obviously you can do anything in any programming language, essentially. Any one that you might reasonably pick, what is Turing complete. But it's a lot harder to do it in certain languages. Python has gained so much traction that there's a huge amount of community packages. It's really effective in web development, backend services there. It's great in robotics. It's one of the 2 primary languages of ROS, Robotics Operating System, with, of course, C++ being the other one. But nonetheless, there's a ton of packages. And then when it comes to machine learning and data science, you've got the Pandas package, you've got things like TensorFlow and PyTorch. There's just so many effective frameworks, and they're so much quicker to prototype and play around with in Python than they are in C++. You don't have to download these big libraries, figure out all your dependencies. I mean, maybe a little you do, but generally you can use an environment like Conda if you can't figure it out yourself and get everything set up really quickly. And then you can just really get in there and solve the problem that actually needs to be solved, which is not how do I build a framework around an ill-defined problem? Because when you are starting out with a new product, your problem is probably ill-defined if it's not somebody else would have done it by then. So your goal is to really clarify and understand the product and the market. And so you don't want to be spending time building code that may be irrelevant. If you have to pivot, you have to ask yourself how much of this code is fundamental, is core. You know, should you be building a platform around something that may not even make sense as a product? And so that is just another argument to why you want to do things as quickly as possible. And when it comes to versatility, being able to take code that somebody else has written from GitHub and being able to just like use that immediately to solve the actual, maybe let's say engineering or product challenge, versus, hey, let me design my own neural network. Right now, I mean, I think you look back like in 2012, like the guys had to program YOLO, right? AlexNet, whatever. They had to obviously write their own neural networks, but because there was nothing at the time. But very quickly, people realized, hey, whoa, this is like, especially with AlexNet, whoa, all of a sudden these neural networks, they can really classify things. This is going to be huge. And so, of course, TensorFlow came along and so on. But really, what that means is, hey, so I don't have to write TensorFlow. I can look to these big companies that put hundreds of millions of billions and more of dollars into developing these frameworks. And so when doing a startup, when building a product, you may have to build your own code, but ideally, you don't have to do that. You can be a lot more effective just piecing together and even duct taping together different modules at a very high level, ideally at the highest level possible. Now, people are going to argue, oh boy, that's so complex. I have to understand how all these packages work. Well, it's better to only understand, especially if they have a narrow interface and deep functionality. It's going to be much better to only have to understand that narrow interface and the behavior contracts, like what does it do, how do I use it, versus, whoa, how does it work under the hood? So I think that's misleading when people say, hey, you should write your own code because it's like less complex. That's rarely the case in 2023. And when it comes to versatility, another great feature of Python is you can really use it throughout your organization. You can do your backends for web services using really simple stuff like Flask and Django. You can do your other types of backend services. You can do robotics applications. You can do machine learning, any kind of really simple application scripts, all of that. And that means that you can hire people that know Python and they can kind of work within various different parts of the stack more easily, as opposed to, oh, maybe I did my backend in Ruby and on Rails, and now it's can't really even find people who do that language, and they get paid so much. So with Python, I think you have a lot, because of its versatility and its ability to work up and down the stack. You're going to be able to staff a team with a more unified tech stack, and that's just going to be more efficient. So when it comes to versatility, in my mind, Python it's just one of the clear winners. I mean, there's other great languages out there, and C++ has tons of packages, but when it comes to versatility, especially in machine learning and the new exciting applications in robotics, Python is really the place to be. And not to mention, if you do have C++, a lot of times people will wrap C++ using like Boost Python or PyBind 11 or other technologies that allow you to basically invoke the C++ directly from the Python. And so you can kind of get the best of both worlds if absolutely necessary. And one benefit of doing that, I might add, is that then you could do the actual iterating, prototyping, the part where you're actually having to change things and learn in Python, and not having to do that in C++, where it's 1/10 the speed and you're compiling and let me go get a cup of coffee. I got to run the linker again. So overall, for versatility, Python, clear winner in my mind. Number 3, scalability and performance. Okay, now this is where you're going to hear most of the arguments against Python. People are going to say, well, geez, Python manages its own memory and you can't even tell the computer to do exactly what you want it to do, and boy, can you even get really good performance out of Python? And the answer is yes. Yes, you can. In fact, you can do numerical computing pretty effectively with NumPy. In my experience, it could be half the speed of C++ or even equivalent in some cases. In a lot of cases, these Python libraries are invoking C under the hood using like Cython or something. So, Python is really just the facade that allows you to tape them together and to do so effectively and avoid any compiling steps. Now, when it comes to scalability and performance, again, the point of this video is to say, hey, what should you do in a startup? Not what should you do when you reach 1 billion users. I think when you have a lot more users, efficiency really matters. For example, Python is not that efficient. It takes more electricity, it takes more power. At a small scale, that's totally irrelevant. But if you're running enterprise grade, world scale software on the cloud, you really want to cut down your compute resource usage. It's going to save you a ton on costs. As I mentioned, Python is such an easy language to get into that typically a Python programmer may not be as experienced as like an experienced C++ programmer, for example. There's more of them to hire, but finding ones with the right experience, especially in high performance, can be somewhat challenging. But again, doing a startup, the key is to get to market quickly. And so scalability and performance may not matter. You probably don't have that many customers. And if you do make something and it just blows up and you get a ton of customers, well, that's a good problem to have. It's a very easy leap of faith to believe that you can then go and take the key performance critical parts, maybe even rewrite them in C++ under the hood if you need to. And if you have found a product market fit, something that actually does that builds a successful business, you're not going to have any problem getting funding and therefore hiring the people and then solving your scalability and performance issues. So don't be tricked into thinking, oh, we want to build it to be scalable and performant from the beginning. That is not what you're optimizing for. What you're optimizing for is figuring out what the heck you're actually trying to build. You're going to get so caught up doing scalability and performance, and then you're going to keep pivoting and iterating because you never know what you're building going in or what you need to build. And so the more you do that, the more the code that you wrote becomes irrelevant and means you just kind of wasted resources, so you weren't very efficient. So for the sake of efficiency, you want to get to the point where you can say, hey, this isn't going to work. They call it fail fast, right? You want to get there as fast as possible. So instead of spending a week writing high performance C++, can you spend a few hours or a day writing a pretty good performance Python? And then be like, well, okay, I'm glad we did that because this idea is never going to work. Based on customer feedback, we need to change it in the following ways. And then even if you do want to argue, again, that Python isn't that kind of performance and maybe you can get 10% or even 50% better performance from C, C++, that may not matter. Computers are just so fast these days, and the ability to perform these computations, especially in the areas where you could be potentially spending a lot of time optimizing, it may just be completely irrelevant. A lot of big tech giants use Python extensively, and they've managed to scale and get high performance out of Python. There's even like a bank version of Python. I can't remember exactly what it's called, but there's like a bank version of Python that's, higher performance and et cetera, and has some of the qualities you would need in the banking industry and finance. That statement could have been true 20 years ago, but we really ought to re-examine our beliefs, especially when they're old beliefs and based on technology, which is an industry that's just growing exponentially and evolving quicker and quicker by the day. When you're building a startup, you need traction. When you get the traction, then you can worry about scalability and performance. Again, if you get traction, not having a scalable system, you can live with that. That's a good problem to have. Okay, so we discussed what I think are very compelling reasons why when you're doing something new, doing something for the first time, building a startup, you should use Python or maybe another high-level language, but you should basically be using Python. Avoid C++, avoid languages that are slow in terms of development speed, that don't have wide community support, where you're going to struggle to find people who understand them well. You don't want to build an organization on a programming language that's fairly esoteric because it's going to be really hard to staff it. It's going to be one of the bottlenecks to scaling the company. So in general, Python seems to me to be the best choice in 2023, and that is what I would recommend. Now, if you think I'm wrong about this, you might be right. Leave a comment below and let's have a conversation about it. I'm really curious to hear, did I miss anything critical? Are there other reasons why, Python wins out over C++? Maybe leave those in the comments as well. Finally, let me just say, there may be situations where Python is not the right choice, but I would be very skeptical of such situations because most of the people I've talked to and the situations I've come across, I can't even really think of a good example where C or C++ would be a better option than Python. At least not for an early stage. So that's the video. Thanks again for watching. Leave some comments below. Don't forget to subscribe and smash the like button. Thanks, and I'll see you next time.